Derecho. A derecho is a type of land hurricane crossing continents, producing hurricane-force winds across areas the size of several states simultaneously. Derechos flatten everything in their path by delivering sustained high winds across wide fronts, unlike tornadoes that affect narrow paths. Strong winds above, instability in the lower atmosphere, and thunderstorm lines are all necessary for the formation. The storms form bow-shaped structures hundreds of miles long, organize into squall lines, and become self-sustaining. Storms cause cold air to sink and spread outward at ground level, resulting in winds over 100 miles per hour throughout the front. Derechos move fast, sometimes traveling at 80 miles per hour, and they arrive with clear skies ahead, which makes them particularly dangerous. The day seems normal, hot, and humid, then suddenly a wall of dust and wind appears on the horizon. The 2012 derecho crossing from Chicago to the Atlantic killed 22 people and left millions without power for days. Katabatic winds. They are cold and dense airflows that move downhill under gravity, often becoming strong and sudden as they descend. They form when cold air builds up over ice sheets or at high altitudes, then falls by its own weight and unexpectedly accelerates to hurricane-like speeds. Antarctica experiences the coldest and strongest katabatic winds. The air cooled to -50 degrees Fahrenheit or below drains off the polar plateau and accelerates down glacial valleys. These winds regularly exceed 100 miles per hour and sometimes reach speeds over 200 miles per hour. The wind isn't just strong, it's so cold that exposed flesh freezes in seconds. People describe these winds as the most terrifying weather phenomenon they'd experienced, materializing suddenly from calm conditions. The invisibility and sudden onset make them deadly. People working outdoors or camping have been blown off cliffs or into freezing water. Atmospheric rivers. Atmospheric rivers are narrow bands of concentrated moisture flowing through the atmosphere from tropical oceans toward land. They are completely invisible until they produce precipitation. These features transport enormous volumes of water vapor, sometimes exceeding the Mississippi River's flow of liquid water. When atmospheric rivers make landfall and encounter mountains, moisture condenses rapidly. The result is intense precipitation that can continue for days. The western US and South America experience these events. The moisture plume extends thousands of miles, funneling tropical moisture toward the coast in concentrated bands, often only a few hundred miles wide. A single strong event drops several feet of rain on mountain slopes in 48 to 72 hours. Ground saturates, streams become raging torrents, hillsides fail in massive landslides. Unlike typical rainstorms that pass in hours, atmospheric rivers maintain steady, heavy precipitation for multiple days as the moisture plume continues to feed the system. Slow slip earthquakes. Beneath the Pacific Northwest, tectonic plates are moving right now in a slow and continuous creep that releases energy over months or years. Scientists discovered these strange events only recently by using special sensors precise enough to measure ground movements to the millimeter level. They involve the same fault movements as normal earthquakes, but spread out over time. The 2011 Tohoku earthquake disaster in Japan may have been preceded by slow slip activity that primed the fault for catastrophic rupture. CO accumulation. Carbon monoxide from volcanic and geothermal sources pools invisibly in valleys and depressions, creating death zones that give no warning. This colorless, odorless gas accumulates to dangerous levels overnight when the air is still, and cold inversions trap it near the ground. People sleeping in vehicles parked in the wrong spots, hikers camping in sheltered valleys, or workers entering buildings in geothermal areas have died from CO poisoning unrelated to combustion. The killing mechanism in the body is insidious. Carbon monoxide attaches strongly to your red blood cells, so these cells can't carry oxygen to other areas in the body. Victims die without ever realizing they are being poisoned. Mammoth Mountain in California releases significant CO from soil, killing trees and occasionally endangering people in enclosed spaces. Without CO detectors, there's no way to know you're in danger until symptoms appear. Temperature inversion. Temperature inversions trap pollution near the ground, like a lid on a pot, then turn cities into gas chambers where air becomes progressively toxic as days pass without wind. As you know, air temperature generally decreases with altitude, allowing polluted air to rise and disperse. But during inversions, warm air sits above cold surface air, preventing vertical mixing and trapping everything beneath. Cities in mountain valleys are particularly vulnerable. Salt Lake City, Denver, and Mexico City all experience severe winter inversions that last for weeks. Cold, dense air settles into valley basins, and surrounding mountains block the winds. As a consequence, a layer of warmer air forms above, creating stable stratification that no weather system disturbs. Vehicle exhaust, industrial emissions, and combustion of all kinds add pollutants to this trapped air mass with nowhere to go. During major inversion events, hospital admissions for respiratory issues spike dramatically. The 1952 Great London Fog was an extreme inversion lasting 5 days, killing an estimated 12,000 people. Smog events. Photochemical smog forms when sunlight, stagnant air, and pollution combine to create a toxic soup. Human-caused emissions release toxic gases and volatile organic compounds into the atmosphere. Sunlight provides energy, and weather stagnation favors the reaction of these compounds, creating dangerous pollutants that attack lung tissue. Los Angeles pioneered smog due to its unique geography and climate. The city sits in a basin surrounded by mountains, with millions of vehicles producing emissions. Sea breezes push polluted air inland, where it hits the mountains and stagnates. Intense California sunshine drives photochemistry, creating brown haze that burns eyes and makes breathing difficult. Smog exposure can cause permanent damage to the body and severe lung inflammation. Repeated exposures cause scarring and permanent lung capacity reduction. People who grow up breathing smoggy air develop smaller lungs and reduced lung function that persist for life. Limnic eruption. Cold water at depth can hold enormous amounts of dissolved gas under pressure. Volcanic activity beneath or near a lake releases CO2 that then dissolves into deep water. The lake literally becomes a carbonated beverage waiting for disturbance. A landslide, earthquake, or destabilizing temperature change can trigger sudden overturn, bringing deep water to the surface where pressure drops and dissolved CO2 comes out of solution instantly. It's similar to dropping a can of soda from the fridge and watching it violently release gas. Lake Nyos released over 1 million tons of CO2 in minutes in 1986 without warning. The gas flowed down valleys, and people sleeping in villages as far as 20 miles away suffocated in their beds. Radon gas release. Radon seeps silently from the ground beneath homes and buildings, accumulating in basements and lower floors, where it exposes residents to radioactive decay products, causing lung cancer. This invisible, odorless noble gas forms naturally from uranium decay in soil and bedrock and is present almost everywhere, but can reach dangerous concentrations in specific geological settings. Areas with granite bedrock, uranium-bearing rocks, or proximity to fault lines experience elevated radon levels. The gas migrates through soil pores and rock fractures, entering buildings through foundation cracks, gaps around pipes, and porous concrete. Once inside, it accumulates in poorly ventilated spaces. Each radon atom that decays emits radioactive particles, which can damage lung tissue when inhaled. Years of exposure accumulate mutations, eventually causing lung cancer. Radon is the second leading cause of lung cancer after smoking, responsible for thousands of deaths annually. Seismic gas emissions. Fault zones don't just produce earthquakes, they also release gases from deep earth that can poison the surface air without any shaking. Before major earthquakes, stress in rocks forces dissolved gases in lava upward through newly formed cracks. Then, during earthquakes, fracturing opens pathways for deep gases to reach the surface. After the 1995 Kobe earthquake, hydrogen sulfide released from damaged ground killed several people entering the affected areas. However, it's important to note that the gas release doesn't perfectly correlate with earthquake timing or magnitude. Small tremors might release significant gas, while major earthquakes might not. Atmospheric pressure waves. When major weather systems clash or storms generate extreme updrafts and downdrafts, they create pressure waves that propagate through the atmosphere at the speed of sound, much like the pressure pulse produced when you clap your hands together. These invisible disturbances can cause physical harm to humans and structures, even though they produce no visible wind or precipitation. Sudden pressure changes affect the sinuses, ears, and lungs. People report feeling punched, experiencing sharp pains in the head or chest, or their ears popping repeatedly. In extreme cases, pressure differentials can cause barotrauma, rupturing eardrums. Cold wave events. Extreme cold kills through multiple mechanisms, all invisible until people start dying. Unlike blizzards, which announce themselves with wind and snow, cold waves can occur under clear skies with little wind. When Arctic air masses flood into populated mid-latitude regions, temperatures drop by 50 to 70 degrees in hours. The human body handles moderate cold easily, but extreme cold overwhelms defenses. At temperatures below certain wind chill thresholds, exposed skin freezes in minutes. Even covered skin loses heat faster than the body can produce it. The 2021 Texas cold wave caused hundreds of deaths, many dying of hypothermia inside homes that lost power during the crisis. Arsenic in groundwater. Millions of people in some regions drink water contaminated with naturally occurring arsenic. They are unaware they are being poisoned until symptoms appear years later. Arsenic comes from geological sources, leaching from rocks and sediments into aquifers, supplying drinking water wells. Certain geological formations, particularly young alluvial deposits in river deltas, contain arsenic-bearing minerals. When oxygen-poor groundwater contacts these sediments, chemical reactions release arsenic into solution. Water looks clean, tastes normal, and gives no indication of contamination without laboratory testing. Chronic arsenic exposure causes horrifying health problems. Internal organs suffer progressive damage, and cancer rates soar. It is also known to have devastating effects on brain development. An estimated 35 to 77 million people drink arsenic-contaminated water that originates from wells. Many remain unaware of the risk, and testing the wells is expensive and not universally available. Cyanobacteria blooms. Warm temperatures, nutrient pollution, and stagnant water combine to create conditions for explosive cyanobacteria growth. They are a type of bacteria capable of producing potent toxins that poison water supplies, kill local aquatic life, and sicken humans who come into contact with or inhale contaminated water. Blooms appear suddenly when conditions align. Heat waves warm nutrient-enriched lakes, and these bacteria multiply exponentially, doubling every few hours. Within days, the water's surface is covered with green scum that looks like spilled paint. The bloom depletes oxygen, killing aquatic life. Exposure to contaminated water causes nausea, vomiting, and diarrhea. Chronic exposure causes liver damage and increased cancer risk. The water can be contaminated before visible blooms appear or after the bacteria have vanished, but toxins remain. If you liked this video, don't forget to subscribe. I'll see you in the next video.